Welcome back, everybody. This is the last section of Unit 5, taking a look at electrolytic cells. This entire unit has been talking about voltaic cells along the way. So what the heck are electrolytic cells? Electrolytic cells are a non-spontaneous redox reaction. And the reason we can call it a non-spontaneous is we can actually force it to do this by adding in electrical energy to force things into the reaction by pumping electrical energy into the system. So pretty straightforward concept. The battery is going to act as an electron pump then, pushing electrons into the cathode and removing them from the anode. This is opposite of what it wants to do, but we can force it to do that by adding energy. And this is what we call electrolysis, pumping the electrons into the redox reaction, okay? Forcing it to go, and you guys are going to find that you'll pick up this one part pretty fast, even though the concept seems kind of weird. There is a simple relationship between the amount of electricity passed through an electrolytic cell and the amount of a substance. What does that make you think of at this point? An amount of a substance should make you think of the mole in chemistry. So going back to how the mole relates to all of this, and the amount of a substance produced by the oxidation and reduction at the electrodes. So if we take a look at these types of things going on, silver will require 1 electron, copper will require 2 electrons, and gold will require 3 electrons to get it to form those products in there. Okay, so we're going to pump in those electrons along the way. And so since we can do that amount of a substance, we can say that 1 mole of electrons will force 1 mole of silver into there. So this is just basic stoichiometry. I have 2 moles of electrons will make 1 mole of copper, and 3 moles of electrons will give us 1 mole of gold. And then we can figure out our masses. Okay, so this is what we're doing with the concept of electroplating. We're going to be actually depositing amounts in there and basically just doing stoichiometry with it. Now, to do that, we have to get a couple more things in our under our belt, and these are values that are going to be given on our AP resources, but we have this idea of the quantity of electrical charge. We don't do it necessarily in terms of volts in there. We do it in terms of something called coulombs. And we have the amps, the rate at which it's flowing, which is a function of the coulombs per second. And then we also have the amount of electrical energy in terms of joules. Now remember, when we're dealing with things like the Faraday's constant, that's in joules or kilojoules. So be super careful which value you use here. So notice that your coulombs minus your voltage will give us our joules. So it's, again, just plug and chug type of thing. And let's take a look at an example of number 12, taking a look at this example of what's going on here. Now we want to know how many grams of gold are going to be, or sorry, of chromium are going to be plated with a certain number of coulombs. How long will it take for one plate to plate 1 gram of chromium using a current ampere? And then if the voltage is this, so notice what I'm providing for you guys. I'm providing some examples of coulombs. I'm providing some examples of amps, and we're applying some examples of my joules. So remember my coulombs. We know that we have 1 mole of electrons equals 9.648 times 10 to the fourth coulombs. We know that with amps, we know that 1 amp is equal to 1 coulomb per second. So there's your time factor. And then lastly, we have joules. Okay? And joules is an amount of an electrical energy. 1 joule equals 1 coulomb times my voltage. And since we're talking in terms of time, let's add in one more thing, and this is an idea of kilowatt hours. Okay, so again, an aspect of time, and we abbreviate kilowatt hours with a lowercase k, and then we have a big W, and then lowercase h. And so 1 kilowatt hour equals 3.6 times 10 to the sixth joules. Okay, so now we should have all the tools to do this type of problem. We want to know how many grams of chromium are going to be plated by 1.00 times 10 to the fourth coulombs. This is just simple stoichiometry, guys. Don't let it intimidate you. 1.00 times 10 to the fourth coulombs. Well, what do we know about coulombs? We know that coulombs equals moles of electrons. Okay, so I'm going to be referring to that one right there. We can then say, when I have my moles of electrons, from my balanced equation, I see that moles of electrons can go to moles of chromium. Again, what's the question? How many grams of chromium? So if I take a look at that balanced equation, I see that I've got 12 of these for every 2 of these, and the problem's just about done, isn't it? I can go moles of chromium then into grams of chromium. So now I end up with a label of grams of chromium. Let's plug in our values, please. We have 1 mole is 52 grams. I see that we had 12 moles of electrons, gave me 2 moles of chromium, and 1 mole, this was just a constant of 9.648 times 10 to the 4th coulombs. So what I end up with is 0.89 grams. I have plated my metal with chromium. Make it nice and bright and shiny. All right, so there's A. I take a look at letter B. How long will it take to plate? So I have 1 gram using a current of this. So I see my amperes. Notice it's in seconds, and so I can do all of this. Now I have 1 gram of chromium that I've got. Let's turn my grams of chromium into moles of chromium. From there, I can say my moles of chromium into my moles of electrons. Now, why would I do that step? I would do that step because then I could see from all these, oh, I can go into coulombs. All right, so from my coulombs, I could go moles of electrons to coulombs. And now, because I'm looking at time, I could take a look at coulombs. Now remember, amps are coulombs divided by seconds. So if I get coulombs by itself, I have coulombs to amps times seconds. Okay, so notice that I've got everything in here, and I want just time. How long will it take? So let's get rid of my label of amps, and I'm given amps right here. That was 6.00 amps. Everything will cancel out here except for seconds. So let's go ahead and plug in 1 coulomb. That ended up being 1.11 times 10, let's see. No, I'm sorry. That ended up being one of those to one of those. And so then I had, in this case, I had 1 mole of electrons. Gave me 9.648 times 10 to the 4th coulombs. I had 2 moles of chromiums to 12 moles of electrons and 52 grams to 1 mole. And so what I end up with in this case is 1.85 times 10 to the 3rd seconds. Okay. Now lastly, we're taking a look at letter C. Okay, if the applied voltage is this, how many kilowatt hours? And so we're actually looking for this one, aren't we? All right, so I have 1 gram, again, of chromium. Now, rather than do all of this math, well, I guess I can go ahead and do that. But basically, I have 52 grams of chromium per mole. I was going to shortcut it, but this is actually pretty fast. It's not too bad. We have 2 moles of chromium to 12 moles of electrons. And then 1 mole of electrons to 9.648 times 10 to the 4th coulombs. And then remember, 1 coulomb. Now, if I'm going to do this, I'm going to go to joules. And the reason I'm doing that is because I'm going to use kilowatt hours. See, and that's the trick, is you've got coulombs here, you got coulombs here, and you've got coulombs here. Which one do we use? Since I'm going to kilowatt hours, I just go 1 coulomb times volts is 1 joule. And then I apply, with all of this, my 4.5 volts. Okay, now remember, with all of this, that will get rid of my voltage. That will get rid of this. So I'm going to end up with just joules in this case. Joules in this case is 5 times 10 to the 4th joules. And remember, then I can go from joules to kilowatt hours. 1 kilowatt hour is 3.6 times 10 to the 6th. Okay, so that's going to be in joules. Okay, so I end up with 1.4 times 10 to the negative second kilowatt hours. Now remember, if you get a negative second, all that really means is 0.014 kilowatt hours. So sometimes people freak out. These two say the exact same thing. All right, that is Pretty much it for those types of problems. It's just stoichiometry. The tricky part is just keeping on top of the four different equations with that. We're going to be electroplating on here. We're going to be calculating the time. We're going to be doing all those things. But again, this is just basic algebra with it. We don't have to worry about too many things. All right, good luck, you guys. This wraps up the entire unit. So welcome to the next test.